man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
Welcome to another episode of the Concrete Logic Podcast. And today I have Shaun Lane, founder and president of NanoCrete, with me today. And we're going to talk about graphene in concrete, which is a great topic because we've never talked about it before, Shaun. So this will be good. But before we get rolling into the podcast, just to remind everybody, there's 3 ways you can support the podcast. And if you're listening and this is not your first time you've heard this before, but just to remind you, the show needs your support, and then that's what keeps us going here. So the first thing you can do is share the podcast with a colleague or a coworker, anybody else that you think would be interested in what you hear today. The second thing is, if you go to concretelogicpodcast.com, there are a couple ways that you can reach out to me. The first one is there's a contact button on there. You can click on that, or on the bottom right-hand corner of the homepage is a little microphone. You can click on that, and that will leave me a voicemail. So those 2 ways of reaching out to me. What I'm looking for are, I can't talk today like I told Shaun before I record. The things I'm looking for from you when you contact me are topic ideas or guest suggestions, because I want to put out episodes that you actually want to hear. So unless you guys start submitting topics or guests, you're going to have the people that I want on, and I don't know necessarily if that's who you want to hear from. So please give me suggestions. And then the third way is on that same homepage, concretelogicpodcast.com, there's a donate button, and on there you click on the donate button, and then you got a couple options on there. You can click on the option that says give any amount to the Concrete Logic Podcast, or I think the other option is like a $10 a month subscription kind of thing. But the whole point of this, folks, is that this podcast is based on a value for value model, which I don't know if y'all listen to any other podcast, but one I would highly suggest you listen to is the No Agenda podcast with Adam Curry and John Dvorak. They've been running a podcast on the value for value model for 16, 17 years now. So I know it works. And that's why I base this podcast on. So what we do here is we provide a value. We provide the information that like Shaun's going to share with us today. And then you come back and you tell us how much that was worth to you. Any amount is appreciated. So don't be shy. All right, Shaun, with that, let's roll into it. So Shaun, if you want to tell a little bit more about yourself and your company and why the heck you're so interested in graphene, and then we'll roll into what the heck that is and how that we use that. I guess we use that in concrete, which I didn't know till today. So yeah, Shaun, go ahead.
Happy to. Well, first off, thanks for the time, and I really appreciate the work that you do with this podcast, Seth. So thank you for your efforts. A little bit about me. I am a Colorado native, born and raised here, and a big fan of outdoor nature. Love hiking, love all of that. My background actually is not in concrete construction, so I'm a bit of an outsider coming into this industry. I spent the last 8 years as an independent property and casualty insurance broker. So over the last 8 years, I got to see firsthand the increasing number of wildfire incidents, floods, and the biggest thing was seeing the insurance companies not actually invest in new technologies to help mitigate some of their losses due to increasing events because of climate change. So why I got interested in graphene was graphene has a lot of potential. It has always been categorized as a wonder material since it was discovered in 2004. And why I found it to be most useful for concrete applications is because a tiny amount of graphene, we're talking 0.0001% of weight by volume of graphene in concrete, you can see significant performance improvements. So in terms of dollar value, it's an advanced material that brings the highest dollar value to the concrete industry. But it had never been implemented before because graphene has previously just been so astronomical to produce. So why I started NanoCrete was to really help drive implementation of this wonder material into concrete at scale. And there's been some significant manufacturing benefits and updates to graphene that have really brought the cost to a point that concrete companies can utilize it and actually make money from utilizing it. So a little background, just to give your audience a little background of what graphene is. All graphene is carbon atoms linked together atomically in a two-dimensional configuration. So think of like flat sheets of paper, but of pure carbon atoms. And why that matters is because graphene has the highest surface area of any known material on the planet. And with that increased surface area, what we're able to achieve is a much more materially efficient concrete mix. So the increased surface area is increasing the adhesion of all your aggregates, your binders, and everything together. So it's making a more stable mix. So for other applications, it's really helping with the concrete pumping because it's helping to maintain the lubrication layer in the concrete pumps and equipment. And for shotcrete applications, it's really helping reduce the amount of rebound loss that occurs when it's sprayed.
Okay. So I have all of our guests fill out just for the folks that are listening. Each guest fills out a form for me now, and I ask what you want to talk about. So in there, Shaun put in graphene is a carbon nanomaterial. What the heck is a carbon nanomaterial?
It's just literally carbon atoms at the atomic or nano scale. So if you think of just carbon atoms themselves connected together atomically, and if you know what a honeycomb looks like, the 6-sided honeycomb type shape, a hexagon, that's how they're arranged in that atomic structure. It's technically called an atomic lattice, but I don't want to get too technical.
So it's not a natural product. It's manufactured. Is that right?
It is a natural material. It's just very rarely found in nature. So graphene, if you think of it as two-dimensional sheets, the three-dimensional version of graphene is just graphite. And we're all familiar with graphite. So
right.
How graphene was initially discovered was researchers in 2004, they literally took Scotch tape to graphite and removed layer by layer of the graphite to get to the individual graphene sheets. So that's how it was discovered 20 plus years ago. How it's been manufactured nowadays is a process. The typical process is called chemical vapor deposition, which all that is you're taking a gas that has mostly carbon in it and you're depositing those carbon atoms onto a substrate. And those carbon atoms then link together automatically into those graphene sheets. So it's a bit of advanced chemistry here, but it is palatable and it is available to the masses nowadays.
So how did you run across it, and why did you think, and I guess decide it was something that concrete needed?
Yeah, so this wasn't just thought up in a vacuum. There's been a lot of lab research implementing graphene into concrete over the last 15 or so years. But the challenge has always been, how do you go from the lab to the actual real world? And there's been some companies that have tried, but they've tried with different methods of graphene implementation into concrete, like a dry powder or other suspension. Where our company is different is how we suspend the graphene. So it's a lot more stable and it's a lot easier to use. But we won't go into product description. Really, the innovation is getting graphene at significantly lower cost and delivering it in a substrate that's easy to use.
So it is would we consider the way that you're using it, would it be considered like an admixture for concrete?
Precisely.
Or is that okay?
Yep.
Not like a fiber reinforcement, nothing like that. It's an admixture, more of that realm.
Correct. It's considered a liquid admixture, but it's more of a jelly as opposed to a true liquid. So it's, how do I describe it? It's like a non-Newtonian fluid. So if you think of like Jello, it kind of looks like Jello and it acts like Jello, but it's mostly graphene.
So when you are looking at the product, are you looking at it under the standard of ASTM C494?
Yes.
Is that what?
Yep.
Okay.
Type S specifically.
Type S. And explain Type S.
Type S is just the type of admixture. So it's a non-metallic admixture.
Yeah. No, type A is water reducing, B is retarding, C is accelerating, D is water reducing and retarding. Type E is water reducing and accelerating. And then it ends.
Yeah,
I didn't see Type S.
Yeah.
Oh, there it is. Specific performance admixture. So it's okay.
Yep.
So what do you have to do? What do you have to do to? We've talked to other folks that are that've been working on stuff for years and under the same ASTM and trying to convince people to use it. So right. Can you talk about a little bit about how what work you've done so far and how you're convincing folks to give it a try and what applications are you using it for so far?
Yeah, absolutely. I appreciate that. So we're undergoing the C494 Type S testing right now. We got our 28-day data very recently, and that's all shown nothing but positives in terms of increased viscosity and increased abrasion resistance. But most importantly, what we've been testing our technology in is for concrete pumping applications and for shotcrete applications, as well as 3D printing applications, but mostly the first two. So for concrete pumping, we've been able to preliminarily see pumping pressure reductions of up to 40%. And the reason why we can show those reductions, as I mentioned earlier, the graphene is enhancing the lubrication layer between the concrete slug and the equipment itself. So it's basically lubricating the layer and lubricating the equipment as the slug is moving through it. So there's a lot less likelihood of resistance, and because of that, we can help show fuel consumption reduction with the technology as well. So graphite, when people think of graphite, they think of enhanced lubricity. Graphene, just being a derivative of graphite, is able to do the same thing, just again with a lot smaller quantities and a lot less.
Okay. And so you said I heard the word you said a moment ago that perked my ear was abrasion. So you've done abrasion, is that right? Testing. So you're trying to figure out a way of making concrete more durable, I assume. What does that work look like? So
what the graphene is doing is, because it's increasing the material adherence at the micro scale, that's ensuring that those aggregates and everything stays together and stays adhered to itself. So that's how we're able to show the reduction of material loss because of abrasion. I don't actually have the numbers in front of me because we're collating that data to put together right now for everybody. But as I said, the data that we have seen from the ASTM 494 has been very positive. Not only does it show that it does no harm, but we are seeing percentage positive increases with the technology as well.
And you're talking about again. I don't mean to circle back and beat this up, but so it's an admixture. It's something you put in the concrete as you're mixing the concrete. This is not an application for afterwards. So are you thinking I understand the pumping. It's going to be easier on the equipment. That's a good thing. Easier to pump. We typically see like a plasticizer, Super P or something like that used for that. A water reducer helps with that, right? I guess how are you competing with that and saying, hey, graphene's a better product than something else, some other admixture out there? What is the advantage of using graphene versus the other things? Have you traveled down that path yet?
No, that's a great question. Really, the biggest advantage that we see is how little of it is needed to achieve positive results. So some of the other technologies, especially like the carbon allotrope technologies, not necessarily graphene, but maybe carbon nanotubes or graphite, those typically require 4 to 5 times the amount of material and technology to achieve the results that we've been seeing with ours. And obviously with that comes with added cost. And for some materials that are in a liquid suspension, like a water or an ethanol based, if you're having to add multiple gallons of water just to deliver this specific technology to your mix, then you're really having to adjust your ratios, your mix ratios. Whereas with our technology and with graphene in general, it literally is just a plug and play. You don't have to change anything to the rest of your mix design. It can be implemented as the last thing to go into your mix, or you could even throw it into the back of the concrete hopper and the back of the hopper truck, and that'll help with the lubrication as well. So it's a utilitarian technology that is no nonsense for contractors and operators and owners. So that's why we're excited about graphene.
So you're not trying to replace anything. So some of the products out there say you can like reduce cement or reduce water or whatnot. So yours is more of an additive versus a replacement.
Correct.
With graphene.
Correct. There's a lot of folks have gotten into trouble trying to claim direct replacement, like 10-15% cement replacement by incorporating graphene. We're just not seeing that yet, and because the data doesn't show it, we're not going to be claiming anything that the data doesn't show. So that's been my whole thesis with this company and with everything that we're going through is we're being data-led first as opposed to claims-led first. Because as you know, the industry, everyone is in a race to be second to use new technology. We're trying to disrupt the industry with graphene, but doing it in a way that makes sense, and we're not coming in with voodoo magic, as it were, or trying to tell people that they're doing everything wrong and that they have to adopt our way of thinking.
So what applications have you used it in so far? I know you're doing testing, but have you used it in a project, in any I don't know, what have you done with it so far?
That's a totally valid question. So we've done a pool project down in Arizona. It was a private pool in a person's backyard. They were having a completely re-shotcrete. So we worked with a contractor there and had it implemented in that project, and that was in early January. We did a project out with Dan McCoy out in Indiana. We did a sidewalk and staging pad on his property. It was about 10 yards of material there. And then we also partnered with a custom shotcrete company out in Colorado. They do rock climbing walls. So we we delivered some of our technology to them and got some feedback from them in terms of how much rebound they saw reduced, and how easy it was to implement into their processes and their overall project timelines.
Do you think what I know so far, just in our last 20 minutes together here, do you feel like your first group of folks that you'll try to work with is the shotcrete people? It just seems like what you're telling me with the ease on the pumping equipment, and things like that, and you just said less rebound and things like that. It sounds kind of geared towards a shotcrete application versus typical, traditional concrete.
Yes, short answer. Shotcrete, gunite, as well as we are looking at regular concrete pumping applications as well. So that's like high-rise applications we're excited about because of, if we can help show those reduced pump pressures, we can help these guys more efficiently place concrete in awkward locations and challenging situations.
Mm-hmm. Are you seeing any increases in strength and compressive or flexural strength in your testing so far?
A little bit, but I'll be honest, that's really not what we're going after, because a lot of other companies and a lot of other technologies have tried that route and they failed because they've been unable to deliver a consistent product to the field. So we've been focusing on the fresh property side of things. But to answer your question, yes, we have seen a slight increase in flexural and compressive strength. So at least people that use our technology know that there is that value added to it as well.
What about consolidation? Are you seeing, I guess, is it consolidating on its own kind of, there's other products out there that claim that. What are you seeing on that side of things? Since you're focusing on the fresh properties, that's why I was asking.
Yeah, we're not seeing any clumping or consolidation, or we're seeing the technology, it evenly disperses throughout the mix. And because so little of it is used, we're not seeing any coloration changes. We're not seeing any bleed water. No, we're not seeing any changes to how it's finished negatively. If anything, for the shotcreters, they're seeing a positive in having increased workability with the technology. So because of focusing on that, I think that we can help deliver immediate value as opposed to having to, tell guys to wait 28 days, 56 days to see those strength increases. We can deliver dollar value right at the job site.
Right. What about I know you said you're focusing on fresh properties, but what about are you looking at permeability at all or anything like that?
Yes, the graphene research shows that there should be a reduced water permeability. We're in the process of testing that with our technology, so stand by for that. But all the research in previous labs have shown that incorporating graphene does reduce water permeability, but not only that, it does help with thermal conductivity throughout the concrete mix as well. That's one of the unique properties, wonder properties, if you will, of graphene, is because of it being just carbon atoms linked together atomically in a two-dimensional configuration. What that's doing with the electrons is it's making all the electrons flow more freely. So it's almost like a conductor, if you will. So because of that, it's helping more thermoregulate more efficiently.
So how do they? I know we touched on it a little bit, and I know you don't want to share a whole lot, but how do they? I guess how do they manufacture carbon? And can you please tell everybody that carbon is different than CO2?
Yes.
Because it drives me nuts.
I'll start with the latter. CO2 is it's a chemical compound. It includes oxygen. Totally different. Carbon is great. You are made of mostly carbon. We are made of mostly carbon. The food we eat is mostly carbon. It's very important to us. CO2 is very important to us as well. But how the graphene itself is manufactured is, I mentioned the chemical vapor deposition method earlier, which again is just taking mostly CO2 gas and depositing it onto a substrate, typically copper. And when it is deposited on that copper, the carbon atoms automatically link together. There's no additional thing that has to happen. They just automatically do it. It's a physical property.
Huh.
The other way graphene is being manufactured is through a process. It's a derivative of a process called pyrolysis. And for everybody, all pyrolysis is high temperature with no oxygen. So if you think of food waste, put it into an incinerator, but without oxygen, what comes out is what's called biochar or carbon black.
Oh yeah. How come I forgot about biochar? Is this one or the same,
it's a derivative
or am
of
I off
biochar.
base
So
there?
the carbon black or biochar, they're one and the same. How do I phrase this? This is an additional process is done to that biochar to convert it to the graphene. So biochar and graphene are not one and the same. Graphene is you could consider a much more pure version of biochar.
So it could be so graphene can be in a produced by another what do I want to say? Could it be a waste material from something from
Absolutely.
a process? Yes.
Our current material is itself produced from waste material feedstock. So that's one of the exciting things, and why I really truly believe that not just our company, but graphene in general is really poised to break out as a material widely adopted, not just in concrete, but paints, polymers, coatings, batteries, superconductors, a whole wide range of applications because of this opportunity to produce it from waste materials. That really opens the doors.
Which industry produces the most waste material that is graphene?
Well, so I think the industry that produces the most waste material that would have the highest likelihood to produce the highest quality graphene is waste lumber. So logging operations, especially here in Colorado, you've got a lot of dead beetle kill and fire kill. So converting that into biochar and then into graphene is a very exciting prospect.
Huh.
But really,
interesting.
Any cellulose-based material, like a food waste, could be converted into biochar and then into graphene too. So anything that's mostly carbon-based, if you throw it into a pyrolysis process, you'll get a carbon black material that can then be converted into graphene.
Huh. Interesting. So, so you said it's getting to a point now that it's economical to produce. Is it because of the waste material, or is it even when you manufacture purposely for graphene, it's economical now?
Yes, and there's been a lot of companies innovating in the graphene production space and manufacturing space in the last 3 to 4 years. So there's really been an inflection of new producers coming online, new feedstocks coming online, new end use cases coming online, such as what we're using it for. Because previously, for the last 20 years or so, graphene was always just a lab curiosity. The joke was always, graphene can do everything except for get out of the lab. Again, that's changed very recently, and we're very excited about that because beyond concrete, well, I won't get into it, but beyond concrete, there's a lot of applications that graphene has the ability to significantly move the needle on as well.
Huh. Yeah. Well, I don't have much more to ask you, Shaun, because this is all new to me and definitely something I need to look into more. What else did you want to hit on before we end today's show?
I'll just touch on a few brief things. So some things to keep in mind is there's been some, how do I put this, some conspiracies with graphene that have kind of floated around over the years of, graphene oxide is some toxic nanomaterial that, can be converted into computer chips that the government can use to manipulate you. Don't listen into the conspiracies of what graphene is. All it is just carbon atoms linked together atomically in a two-dimensional configuration. That's it.
Oh, was that the
Yes.
5G stuff? Is
Yes.
that the same thing?
They were all looped together.
I love conspiracies, so they're fun. That's interesting. What else did you want to share? That's a good one.
We're at the forefront of graphene technology, and we're looking to partner with as many willing first adopters as possible. We know that this is a very conservative industry, rightfully so. Concrete works. It's always worked. So we're trying to disrupt very gently and come with our arm around everyone's shoulder, and say, this is new. This product is new, but the technology itself is not new. Let us show you how it works. Once you see how it works, we're convinced that it'll just be a part of everyone's operations going forward. It makes that much sense.
Yeah. I know you can't speak for Dan McCoy, but what he think? He's the pumping man. What did he say?
He's excited to place a purchase order very soon. So we're getting with him to show the 28-day data from our C494, and once we have that discussion, then Bob's your uncle. We're moving forward with him, and we're in discussions with.
Nice! Congrats.
Thank you. Dan's a great guy, as you know. We're in discussions with other companies as well. So, Thorcon, Shawcrete here in Denver, Brundage Bone, Concrete Pumping. So we're excited with the relationships that we built thus far and looking to build additional relationships going forward. So happy to answer any questions about the technology and graphene going forward. There's a team of, it's not just me, there's 4 of us. So we're here and we're ready and we're excited to be a part of this.
Yeah. So is the goal with the pumping guys is to give them the product to add at the trucks at the site, and it'll have no detrimental effect to the concrete. They won't even know it's there, but it'll be nicer on the equipment.
It's giving them a tool to take more control of their pumping operations. So, if they're getting handed a Type 1L heavy cement mix that they didn't know about, or if they've got some crusher fines in their mix that they weren't expecting, our technology gives them the ability to take back some control of reducing their ever-increasing pump pressures.
Yeah, that's cool. All right, Shaun. Well, I appreciate you coming on the show today, and we'll have to follow along. And this is really new technology. 20 years ago doesn't seem that long ago for me. I mean, so that's pretty new to me. But yeah, you'll have to stay in touch and let us know how things are going. And then next time I talk to Dan, I will pick his brain, see what he says. He probably has a good idea what this will do.
Thank you very much. I really
thank you,
appreciate
Shaun.
it.
And yeah, no problem. Until next time, folks, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
Ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives. Dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't. It's written in our blood with wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that